So the second part of this topic is all about climographs. What are climographs? You know what a graph is? It's a graphical representation, and climo is the link to climate. So climographs are all about typical seasonal cycles. Okay, typical seasonal cycles of temperature and precipitation. Okay, so let's have a look. How does a climograph look like? Okay, show you one climograph for Hong Kong. Okay, climograph is a representation of the monthly mean temperature using a line and precipitation using bars for each month of the year at a place. This one is for Hong Kong. So let me explain to you what's done here and what's shown. The red curve, the solid line here, is monthly mean temperature. The temperature scale is on the left side. Okay, you can see it's around something like maybe 16 degrees for January. The x-axis are the months of the year. January, February, March, you know the months of the year. We are in the northern hemisphere, so we have the winter months include December, January, February, something like that. Okay, so how are the values derived? You look at all available January data and you determine the average. Okay? And you do the same for February, then for March, then for April, and so on. Okay? There are two more red curves. Yeah, one is sort of dotted, and that shows the average minimum temperature. So it's essentially nighttime temperatures, and the maximum temperature are these dashed curves. Okay, and you can clearly see a seasonal cycle. Okay, it's a typical feature, and it repeats because it's an average. It's typical as an average value for all years, and you get the warmest month. You can determine when the warmest month occur. You're in June, July, August, and you can see when the coldest months occur. Similarly, you do it for precipitation. In this graph, precipitation is on the right-hand side and goes from 0 to 50, and the unit is centimeters per month. Although it does not say explicitly here months, but it's centimeter per month because it's monthly data. And you can learn about the precipitation when there's the wet season. You can see from May to September, and you can work out what the rainfall is, and then you can determine the dry season, from January, including November, December, January, February. Okay, and this is a region where you have dry winter. Dry winters and wet summers. Okay, so there's one region. You can do now a comparison with another region. I'll just show you on the next slide. On the left side is Hong Kong, again, what we just discussed, and you can compare it with a region which also has a dry winter climate, also subtropics, and New Delhi in India. Okay, you can look at the temperatures. And now if you compare these two graphs, it's important to make sure that the ranges of the axis, both horizontal and vertical axis, are exactly the same. Because if they are the same, you can visually compare. You can just swap from left to right, and you can see, wow, it's significantly less rainfall, and you can also see that the dry period is much longer in New Delhi. Okay, and that's how you derive the climographs, climate information for regions. And so why people do that is, you can also use the same method, but for subsets. Say you can do every 10 years, you can produce a climograph, for every decade of the past 50 years, and then you can look at changes over time. how has the rainfall changed, and how has the temperature changed. Okay, the seasonal cycle. And that's what climate scientists do to infer changes in regional climates due to global warming. So what I want to do now, as the last part of this second part, is I want to show you climographs for different vegetation zones. Okay, we talked in a previous lecture about different vegetation zones, and I want to just show you the examples of climographs and maybe point out some of the differences. Okay, let's do this. Okay, so here are climographs for different vegetation zones. And let's just focus on the one shown in the top left. Okay, look at that graph. Have a little bit of a break, and then let's have a focus of what is shown here. Temperature is actually it's shown on the right-hand side. Shows you the temperature range. Here from 0 to 35, and this one is for tropical rainforests, or for one location in Brazil. Okay, and this one is actually from the NASA Earth Observatory page, the same one where the different vegetation zones are described. Okay, if you can't find the link, just send me. I will post that on Flow again. Okay, the bars, vertical bars, are precipitation, and the values of precipitation are on the left. But for each graph, the scale is different. You can see here the next one, grassland example, goes only to 140 millimeters per month, and so on. They all change all over the place. In order that you get some means of comparison, I added a red dotted line exactly at 50 millimeters per month. And then you can sort of have a means to visually compare actually between different regions. And if you use that as a guide, the 50 millimeters per month, you can see that in tropical rainforest you have a surplus of rainfall, almost 6 times this reference of 50 millimeters per month over several months. Okay, this 4 months and 6 months, half a year of massive rainfall. So this is sort of the very high rainfall that you can get. Okay, per month. Okay, and 300 centimeters is actually 3 meters. So it's a massive amount of rainfall. Okay. So and you can see the temperature changes very little over the year. Okay, because we are in the tropics. And there is not much a seasonal cycle there in terms of solar radiation. Okay. Then you can compare it with grassland, grassland, and we have much lower precipitation. And the temperature cycle, you still have, you have a seasonal cycle, but no freezing conditions. Here in Texas, in Austin, Texas, it varies temperature between 10 and 30 degrees. It's quite some change, 20 degrees change, seasonal change. Okay, but you don't have, you have rainfall most of the time, a little bit stronger during during May and June, and so anyway. Okay. And then we come to coniferous forest in Finland. Coming to that type of forest in Finland, and here we see something different in terms of the temperature. And what you see in terms of the temperature is actually, if you look at the numbers, that you get a month where the temperature is below 0, where you actually get a frozen ground situation. You get freezing. November, December, January, February, and March. So you have a distinct long winter season, and that has a clear impact on the type of vegetation that you can have. Rainfall is sort of, similar to the Texas, but you have a clear difference in terms of the temperature cycle that you have. Then we go to the temperate deciduous forest, looking at one example in Spain. In this example, you have very low rainfall actually in this area. Really, really low rainfall, in particular over the summer months. Okay, but you have a temperature range which is there is no sub-zero temperatures in winter. Temperature varies between 5 and 25. It's similar to Austin, Texas, but you have a different type of rainfall in this area. Let's continue. I continue this survey. Let's go to the desert. That's the most extreme example. And you might be surprised not to see any red dotted curve here. The reason for that is that the vertical range of rainfall only goes to 35 millimeters per second. So I can't plot a 50 line. Okay, I can't a 50 reference line. Okay. Come to the tundra situation. Okay, in Canada, here in Aklavit in Canada, very low rainfall. Most of the year. Okay, very low rainfall. And you also have a situation where it gets very cold, sub-zero, so very, very cold conditions of no. It's not optimum conditions for trees to grow. So you have treeless plains in these areas. Shrubland, okay. One example, South Africa. Okay, and we're talking about the winter season is here in the middle of the year. Get very, very low rainfall during that time, and that dominates the climate in that area. So with these examples, I just want to show you that temperature and precipitation have similar but different impacts on climate conditions. You have areas where temperature is the controlling factors, and then you have areas where precipitation is the controlling factor. And that brings us to the end of the second part of the lecture.